Hi, it's Jan Beta, and I'm going to continue the struggle with resurrecting the Amiga 4000 that I worked on in the previous video that suffered some severe battery leakage. Yeah, that was a long cut. A significant amount of time has passed since I last worked on the Amiga 4000. And now it's, I think, about a year later or something, partially due to my procrastination of difficult projects like this, and partially due to the fact that I had to order a whole lot of replacement parts. I now got a bunch of things I want to replace, and I also decided on desoldering the RAM slot sockets altogether. So I'm going to desolder those. I also got a bunch of new electrolytic capacitors. I'm going to remove the original SMD capacitors that are on the board. And then I'm going to replace the chips that were affected by the battery leakage. And then I'm going to try to repair the traces that were destroyed by the battery leakage with adding some botch wires. I hope I can get this done. Apologies for the delay. I know for you it's just a second and an edit. But yeah, for me this was on my bucket list for quite a while. So let's continue this. So I'm going to have my little fume extractor running here, and I'm also going to open the window. So you might experience some noise in the background. But yeah, all of these are going to have to go. I bought a complete set of replacement ones that don't have plastic latches for keeping the RAM sticks in place, so they should probably last a bit longer. These are old and probably they are all brittle, so they are all going to break sooner or later. That's the first thing I want to do now. Desolder all of these. And yeah, I have my desoldering station running. I'm going to add some flux to all of these joints here and hopefully get these out without damaging the board. Yeah, this is going to take a significant time. So I'm probably not going to bore you with the whole process. Basically what I'm doing here is to use my desoldering station to get most of the solder out, and I'm going to add some fresh solder to the joints that I couldn't desolder this way and try to desolder them again, and probably going to finish this off with using some hot air to heat the whole area and try to get these out without damaging the board. So yeah, I think I'm going to turn the camera off for this and report back later. So I'm nearly done desoldering these, and I'm slowly wiggling these out while heating the back with some hot air. And there's this plastic lock in the center there that I have to push together with a pair of pliers to fully remove these. And then it's just a matter of slowly applying some heat and wiggling them out carefully to hopefully not damage the board. These plastic nubbins are taking a bit of work. Wow, okay, that one broke off. But yeah, this goes reasonably well. It's just some more wiggling And we're going to get these out without much damage to the board, hopefully. Some of these metal connections just stayed in place, so I'm applying some hot air. These just broke out of the plastic without much force, so we didn't damage any traces as far as I can see. But still, we have to heat up the remaining solder on this side to get these out. Yeah, some of these are so covered with an oxide layer that they are not too easy to heat up, actually. Yeah, this is corroded underneath, so good thing we removed these altogether. So we are going to have to clean this row here up significantly, at least that one. Look at the green spots on this connector here. That definitely saw some battery leakage, and yeah, good thing we removed that, and hopefully we can patch up the connections. There's a lot of them, actually. That was a good idea to remove all that. So trying to clean up with alcohol and removing the remaining solder. Yeah, I'm using solder wick and my regular soldering iron for removing the rest of the solder, I think, and then we're going to see. Yeah, this is certainly not the easiest task. The vias are still there. Should clean up the whole area. Yeah, but these should clean up really okay-ish, at least. Should probably work out. Okay, after some work with some flux and some alcohol and some solder braid, solder wick, it doesn't look that bad. There was some corrosion going on there, and I think we lost half of this pad here, but it should still be all right and making good contact. The connection seems to be on the back side of the board. I think some of these connections might be broken. We're going to use the glass fiber tip pen again to free those up and remove the corrosion. But other than that, this area looks pretty good, thankfully. So there was some more corrosion here that I removed. You just basically want to remove every little oxide or battery acid damaged stuff. So everything that's green and not the silk screen should be removed. I think I got that at this point, hopefully. Yeah, if you're working on a board that is as severely damaged as this, one possible solution, of course, is to get one of the newly redesigned Amiga boards. And in case you plan on ordering a full replacement board for the Amiga, I can recommend the sponsor for this video, which is PCBWay, my favorite manufacturer of prototype boards of all kinds. They also do larger scale projects and their quality is super high. Prices are not that high, thankfully, and they have very quick turnaround times. So I highly recommend checking out the website that is linked in the video description. Now back to the Amiga board that I'm trying to resurrect. So I guess I cleaned this up as much as I could. Next step is going to be replacing all the electrolytic capacitors on this board, especially the surface mount ones, because the ones from this era all leak basically. So 90s SMD electrolytic capacitors, replace them at this point in time, because they have probably leaked or they are about to start leaking, and they are literally leaking electrolyte on the board, which damages the traces in the worst case, or the board in general, similar to what the battery acid does. A little less aggressive with the electrolyte, but still you don't want that on your board. Apart from the fact that the capacitors obviously don't work as they are intended to work if they start leaking. I'm going to do this without talking too much about it. I'm going to use Kapton tape around the spots I want to desolder these, and I'm using hot air to actually desolder these, heating the pins one by one until the solder melts, and then I take them off with a pair of tweezers. And yeah, we're going to clean up the solder, the old solder from the pads, and clean the whole board in the areas with isopropyl. And these ones I'm going to use, these are through-hole capacitors. There's only 2 of them on this board. I'm going to use my desoldering station for the classic way. I did a whole video about replacing these SMD electrolytic capacitors on my Amiga 600 a while back. I'm going to link that in the video description. That's a good reference for this kind of work, or the way I do this kind of work. I know there's different approaches to this. My approach usually is using hot air, and that works rather nicely for me. Most of the times, hopefully this time. So I've now taped up most of the components next to the surface mount capacitors with Kapton tape, which is the heat resistant tape. Prevents the other components from accidentally being desoldered, and also plastic parts from melting, hopefully. There are some pretty tight spots around this connector here, for example, and yeah, we're going to see. I also marked all the old capacitors with a red marker to be able to see if I forgot one. Now for the surface mount ones. For the through-hole ones, I actually ended up using the method of heating the pins with my regular soldering iron and slowly pulling the pins out, because that worked better than sucking the solder out. As I said, this is a multi-layer board, and you need quite a bit of heat to be able to desolder the components, actually. So I'm going to add some flux to all the joints to hopefully clean them up a bit. Some of them are really corroded, so it's going to make that desoldering process a whole lot worse. Yeah, I think I'm going to show this once, and then I'm just going to show you the results, hopefully. So C188, we want to desolder that. I'm just using my hot air and aiming at the pins. And I'm taking turns to try to heat the pads evenly. It's not so easy to do with the camera in the way. Eventually, you don't want to aim at the cap. Sometimes they pop if they are heated up too much. You want to aim at the pads, actually. And then you use a pair of tweezers after you melt the solder, which hopefully is going to happen at some point. It usually does. The solder starts to melt, and you can just pull it off without any force. These are, as I said, these pads are super corroded, so this is not easy in this case. And also, there we are. And also, the pads, if they are corroded, they easily rip off. So you don't want that, obviously. Just take your time, and as soon as you feel it getting loose, you should be good to pull it off. And that's basically how I'm going to try to remove all the capacitors on the board, which are quite a few. think I got them all off. And obviously going to replace them with same values electrolytic capacitors again. This is what the board looks like now. One thing I forgot to mention, there's another of these plastic standoffs close to this capacitor. I removed that by pinching the backside of it and pulling it out to not melt it. And yeah, I'm going to clean the pads where the capacitors were. I don't think I lifted any of them, thankfully. So I'm going to clean that with some solder wick and clean the areas around the capacitors with alcohol thoroughly, because if there was leakage, you want to remove that. So the only one that really doesn't look as good as new at this point is this one we first removed. That got some of the battery leakage. So I'm going to try to use the glass fiber pen to clean that up. And that works really well. Nice. That should do. Yeah, at least that went well. No lifted pads or anything like that. So I'm going to remove the Kapton tape. I think it prevented me from melting any of the connectors or plastics. Soldering the new ones in is going to be a lot easier. Actually, we're going to use the soldering iron for that, the regular soldering iron. I wonder if we are going to be able to make this work at all anyway. So yeah, maybe this is all for nothing, but I still hope I can resurrect this thing. So it's the umpteenth round of cleaning, this time around the capacitors. And under the capacitors, or under where they used to be, which is pretty good. So we can get to that now. I'm not going to show you the whole process. Basically, we did this the whole time. So I removed all the electrolytic capacitors. At this point, I did some initial cleaning up here, and I'm going to do some more cleaning up in this area because I can already see that there's still some smudge left. I just wanted to point out, as I'm about to solder back the new SMD electrolytic capacitors, there are actually two capacitors that are indicated wrong on the silk screen, and they are also put in the wrong polarity from factory. And that's in this audio circuitry. That's C434. It's upside down from this perspective. And C433. These two, which are 22 microfarad capacitors, are in the wrong polarity from factory, and the silk screen is also wrong. The flat side on the silk screen layout usually indicates the negative side, which is the marked side on the capacitor itself for electrolytic capacitors most of the times. Yeah, but these are in reverse in this design. These are the AC coupling caps for the audio output. And if you put them in like this, they are going to work. They are basically just filtering the positive bias that is on the signal before it reaches the output. But they are going to see some reverse bias if they are in the wrong polarity. So we are going to put these in turned around, basically. So they are working correctly. They are going to work with the other polarity as well, but they're going to get a lot more stress. And I think I want to put these two in first, because otherwise I'm probably going to get confused. So I'm basically going to apply a decent amount of flux to where we want to solder our capacitors. I'm going to tin one of the pads with solder. don't need a lot for SMD soldering. And then I'm going to put my capacitor in there, in the correct polarity, which is the one that's not indicated on the silk screen. In this case, usually, and for the other capacitors, it's correctly indicated on the silk screen, at least on this board, as far as I can see. So this goes in the other way around. You can hear the flux activating there. Usually you want to put flux on the component and on the pad. Placing this nicely. And then adding a tiny bit of solder. And this is now facing in the direction, the negative is facing this way, which is indicated on the silk screen as the positive. So yeah, as I said, these are in the wrong polarity. I'm going to repeat the process for the rest of the capacitors. And I'm going to use this rather flashy capacitor map by TSB from 2017 as my guide. And you can see that the capacitor values have different colors, so it's pretty easy to see which value goes where. I'm going to do one value at a time, so I'm using all of the 22 microfarad capacitors first, and then I'm going to go on with the other values. I got all the surface mount electrolytic capacitors in now. Now I'm going for the through-hole ones, the two 470 microfarad ones. This should be easy. Okay, new capacitors are in. Now for the meditative and tedious part of this, I am going to slowly go through all the connections here and put botch wires in for the broken connections. And I'm going to connect, like for example here, you can see that the connections, the traces are clearly eaten away. So I'm going to have to figure out where that via actually is supposed to connect to and then run a botch wire. And I'm going to do some of these before I put the components in, and some of them I'm going to solder to the IC legs and things like that, trying to keep them as short as possible to not get any extra interference. I'm going to use this magnet wire kind of thing. This is ideal for this purpose because we don't need a thick gauge wire, and these are usually you can just melt the insulation and add some solder, and the connection should be made with this. So it's also purple or violet, which I like. So I'm going to try to do this as nicely as possible and not mess this up too much. And I'm actually going to measure all these with my multimeter set to continuity testing and see where they're supposed to go and if they are going there. And some of these I can clearly see that they are broken. Some of them might be broken in ways that are not clearly visible. So yeah, basically I'm going to beep out all the connections on all the components are removed here, and also try if the components we left in place connect to the right spots. That's going to take some time. And thankfully this website exists, which is amigapcb.org. the Amiga PCB Explorer, which has some interactive schematics for some of the Amiga models. They are adding more sometimes. Thankfully, my revision of the Amiga 4000, which is Rev B, is in here. And as you can see in a second, this is going to be super useful for what I'm about to do here. So basically we have our Amiga PCB here. That's the exact same PCB layout I have, and we can just click on any of the connections and we see where they are going. And you can have multiple ones activated at once if you want to, and you can see where they are going and that they are sometimes going to places like here which are not visible as this is a multi-layer board and the traces are super tiny, so this is going to be massively helpful for checking the connections, and that's what I'm going to use. Of course, for other revision boards you probably have to refer to the schematics, which are also widely available online, thankfully. But this is going to make things considerably easier, of course, so I'm pretty glad that I got a revision that's in the Amiga PCB Explorer here. Without further ado, let's just get this going, I guess. Ew. Not looking forward to this. Hope I managed to fix it. So I started here with these three. The bottom one of these three connections is actually alright. I measured that, and the other two I repaired by running botch wires to the next via where they should be connected. Pretty difficult to solder to these vias. I tried to put a bit of wire into the via actually. The vias in this board are usually just used to get a trace from the top side running on the back side. So yeah, if there's a component on the front side, so it doesn't interfere with the trace. So we have our traces remade on the bottom here that are broken on the top side in this case. I think the next thing I want to do is this chip here, and I think most of the connections are still there, but there's two missing on the bottom row of pins here. So I think what I want to do is to solder this in and then run the wires from the two missing connections. Some of the connections are still fine. I beeped some of it out, some of them aren't. So I'm going to go through this pin by pin and run botch wires where necessary. Ooh. First of all, let me solder this chip in, which the replacements I got are from Mauser actually. There's a bill of materials for one of the Amiga 4000 board remakes, and you can find part numbers for Mauser orders in there, so that's pretty handy. You get the exact size of chip you need. These come in different packages for, these are mostly standard logic chips that I'm going to replace here. I'm not going to try to use the original ones, but I got these replacements which should be suitable for the job, hopefully. This is the F245 chip that goes here. So yeah, let me try to solder that one in. Okay, one chip down, 3 more to go. And of course this row of resistors, this resistor package, and all the other connections around here. So I'm slowly going to go through this, replacing the connections with these wires, as you've seen. Yeah, some of these are ground connections. I just soldered them to the next ground, which is on this capacitor. And I hope this way we're going to somewhat resurrect this. This is going to be a bit of work still. So I soldered these 3 logic chips in, and I think I also want to solder replacement surface mount resistors into these positions here before I run the botch wires. And you can clearly see that there are quite a few connections missing from these, and there might be traces that have been eaten by the battery. Yeah, so I'm going to meticulously check each connection on each pin of these 3 chips, and I'm also going to check the resistors once I have those in place. And it's going to be fun. Surface mount soldering on a badly corroded board. Yeah, I'm just going to try. Yeah, they look hand soldered, but the connections should be fine. We're going to find out if the connections to elsewhere on the board are also fine. Some of them are. I've seen that, but not all of them. So yeah, I'm just going to go through this pin by pin and resistor for resistor and see if we can patch this up. So after some hours actually of work, this is where we're at. I have this chip connected back up, I have this chip connected back up. This is half of it is connected back up. This side should be less bad than this side. I had to connect nearly every pin on this side. So this side, the pads at least aren't lifted to that extent, and I hope this one is mostly all right. So we're slowly getting there. I had to make some connections on the back side of the board, so I'm just sneaking my wires around the board here. There's another row of resistors similar to this one on the other side, so some of these pins connect to those. Usually through some vias and some traces, but yeah, those were eaten. Yeah, I'm just going to try to continue this. It is super tedious to do, obviously, and after I soldered everything, I'm going to double check all the connections again. And I think the next step after that should be soldering the RAM sockets back in, but we're not there yet. Also, I have to put the resistor pack in, of course, but to make it easier to check the connections, I just left it out for now. We're going to have to check some of the connections on that, and yeah, the vias are exposed, so it's easier to check. Ugh. Okay, let's continue. Well, I think I got all the connections on the actual ICs back up and running. I'm going to check some of the smaller components, starting with these resistors, this row of resistors, and there's also a row of resistors on the other side. And this outer side of the resistors, except for one on the bottom side, should all be connected to the 5 volts internal 5 volts rail on the board. I actually found a nice method of cleaning those vias that should be connected to the resistors and the 5 volts by just using the leg of a resistor here, which is pretty thin, and I managed to clean out all the remaining gunk from those vias, which is pretty handy. I thought I'd mention this. Yeah, basically what I'm going to do is to go through these resistors and see if they are connected to the correct points on the board by using the Amiga PCB Explorer again that I used for the chips. And then I'm going to double check every single connection again and see if my connections on some of these corroded traces still make contact with where they are supposed to go. And shortly after that, if my connections are correct, I'm going to solder in the RAM sockets, I guess. This continues to be a lot of work. So, okay, let's check some of the resistors. Okay. There we go. So, I checked this side of the resistors facing towards the board. This side should all be connected to the 5 volts rail, which I can check against this capacitor here, which also has the 5 volts rail. So this is connected, this isn't, this is. So the vias are all still there, it seems. But not all my resistors are connected. So I'm going to run some, I think I'm going to use the resistor lead to run from the via to the resistor actually. And the same applies on the backside. So we could probably just connect, like bend a resistor leg to connect on both sides. Maybe that's what I'm going to do. Yeah, I'm going to have to do this a couple of times. So I made these little hooks that I'm just inserting through the vias and soldering them to the remainder of the via and the resistor. Double checking. All connected back up on this side, and the other side should be connected as well. Let's take a look at the bottom side of the board. I found another corroded connection that I'm going to patch up. And usually, if you want to solder to these vias, you have to scrape away some of the solder mask to get to the copper to be able to solder to that. So I think I made all the connections. There's 5 volts on most of these. Second one from the bottom is ground on that side. Let's check the other side of the resistors, and then it's time to double, triple check all the connections again, I guess, and look out for more broken connections. Phew. But I think we're mostly done with the bodging of things. So, I fixed up some other connections. in the meantime. And I'm currently going through all the wiring again that we did on this. And yeah, seems we're good on this chip. That's good. Okay, let's try this one. Going through every single pin again. Just to double check. So I double checked all the connections on all of the ICs. Maybe there's some broken trace somewhere else that we're going to have to figure out, but at this point I'm pretty confident I made all the connections on the ICs and the resistors in the correct spots. I just tinned some of the traces we're not going to easily get to anymore after soldering the RAM sockets in. And that's going to be the next step. I'm going to solder in all these RAM sockets. As you've seen, the original ones had these plastic locking mechanisms, so I got some better ones that actually have metal tabs to lock the RAM in place. These should hopefully fit in here. Are they though? Yup. Nice. Okay. Do they stack or do I have to do some modifications? I think they should fit on top of each other. Yeah, beautiful. Okay. So yeah, that's going to be a lot of solder joints and my next step. Just tagging one pin on each side and then go on and solder in all the pins. This should be a piece of cake compared to the rest of this repair jobby. And I'm using flux because this board, as we've seen, is rather thick. So the new RAM sockets are in and it looks a lot nicer than before with the old sockets, which were really brittle. These should be a lot nicer with these metal locking mechanisms. And yeah, I think the next step is going to be replacing the SMD electrolytic capacitors on the CPU board actually, which plugs in here. I have that disconnected, obviously, to work on the main board, but it is necessary to test this, obviously, because this doesn't have any other means of using a CPU, so we need to plug one in. So here's our little CPU board, and it has 4 22 microfarad SMD electrolytic capacitors on there. Some of the pads look super dull, so they probably have leaked. I'm going to just replace these and yeah, basically taping up the components next to them with some Kapton tape like I did on the main board, and using hot air to remove them, and then using my regular soldering iron to solder in the new capacitors. So yeah, let's do that. Ooh, and it smells fishy, so yeah. This has definitely leaked. Yeah, this one right here clearly had some leakage going on there, as you can see by the corroded pads. I'm going to try to scrape off some of that gunk there. Yeah, should be easy to clean up still. And the pads are still there, thankfully. I'm going to have to clean this really thoroughly with some alcohol as well. Yeah, thankfully the board didn't get damaged as far as I can see by the leakage. Let's solder in the new capacitors. Okay, time to put the processor board back onto the main board. Then I'm going to clean up the mess a bit. Probably going to add some contact cleaner just to make sure. Yeah, then it's going to be time for the first test run, I guess. Whew. Time to cross your fingers. We also need a bit of chip RAM, which this topmost socket is for. And yeah, this should fit in here. Yup. Yeah, at this point, ideally, this should be a bootable Amiga. Let's find out, I guess. I'm not sure if I managed to catch all the broken connections there. There might be some work to do still, but we're going to find out pretty soon. I'm about to power this on, actually. Okay, obviously I have no idea what this thing is going to do. I'm just going to plug it in. I have the monitor hooked up, and hopefully, maybe, we are not going to see any explosions. God, I'm so nervous. Okay, I'm going to flick the switch. Power supply turning on. It's producing a PAL signal. That's a good sign, I suppose. But we got a black screen. It takes a while with the Kickstart 3.0 that's in there to start up, because it's looking for a hard disk drive. Yeah, but this takes a bit too long. This is taking a bit too long. Yeah, I don't think this works at this point. That's too bad. That's going to take some more work, unfortunately. Ow, f***. This chip gets really hot. That's not good. So I accidentally touched this chip here, and I think that one is toast, literally. It's getting really hot. That's no good. But why is that? I don't know if you noticed during this video, but I failed in a massively embarrassing way. Probably some of you were screaming at me all the time, but yeah. It's actually a day later, and I had to take some deep breaths and give myself some massive face palms, because I fitted the logic chips in the wrong polarity. Yes. So all I did, all the botch wires, I'm going to have to redo. So here's a closer look at the mess I made. It doesn't look that messy on first glance. I fitted all these three chips actually with pin 1 facing towards the board. But originally they are fitted with pin 1 facing the perimeter of the board. So these are going to have to go again, and I'm going to have to replace them and rewire all my little botches after spending hours, days, I don't know, a long time checking and double checking, and yeah, pretty devastated at this point. But there's not much else I can do than to remove all the wires and remove the chips and fit new ones, because these are probably toast, because I was stupid enough to power this up. And these obviously got the supply voltages on the wrong pins. So I don't think anything else got damaged, at least I hope so, but I am going to have to replace these chips. That is massively embarrassing and devastating. I apologize. I also apologize to myself. I didn't notice, and yeah, I was just assuming that pin 1 was facing this way. which is wrong. Would have been too easy, wouldn't it? Yeah, this is going to be fun. But at least I have another opportunity of cleaning the board even more. Actually, there's nothing good I can say about this, having to go through this again. The only thing maybe is that I bought spares of the chips, so I have enough chips to replace these. Thankfully, I bought double the amount I needed in case I messed something up, which I did. Just going to go in and desolder my botch wires, and then I'm going to use hot air and Kapton tape to tape off the components surrounding this. And then I'm going to have to reattach my botches here. Yeah, this is not going to be a fun experience. It's a learning curve. At least I only have to fit one end again, resolder one end. Okay, all the wires removed. Now I'm going to try to put Kapton tape over the existing botch wires. And then I'm going to try to remove these chips. I hope you like a good plot twist. This was, or is, the biggest one I've experienced yet. Hope I learned my lesson this time. Now for the fun part of trying to get these off again without damaging the board too much. I'm going to add some flux and then go with the hot air station and try to carefully get these out again. Wish me luck! Yay! That wasn't too bad. Yeah, I think most of the pads that were intact are still intact. Now for fitting the last replacement chips I have. Hopefully in the correct orientation with pin 1 facing out of the board. It's going to be fine. Maybe. Okay, so this is the orientation that these should actually go in. I think I did a reasonable job of resoldering these. I might have lost another pad on this one, but yeah, as I said, if the pads come off easily, they were probably damaged anyway, so it's not really a bad thing. And we are going to have to go through each of the pins individually again anyway and run some botch wires where necessary. As before, I'm probably not going to bore you with the whole process because I did all that. If it wasn't for the chips being in the wrong orientation, it would have been the same process that I'm going to redo now because of my stupidity. Okay, back to the drawing board or the PCB Explorer. This is going to be so much fun. And after some tedious rewiring, I ended up with this, which hopefully is going to have all the connections back that I made previously, but had the chips reversed. So I'm going to double and triple check all the connections using the PCB Explorer again and my multimeter in continuity testing mode, and then I'm maybe going to try to power this on again. Let's see if I did everything correctly. Okay, I double and triple checked all the connections. I checked for shorts. I actually made one wire that wasn't necessary because the connection was there. I just didn't realize last time around. I put one of the RAMs in the chip memory location, which is the first slot here. Hooked up the monitor, hooked up the power supply. I don't know what else to do than to try to power this on again. Fingers crossed it's going to work this time. Not getting anything. But at least none of the chips gets hot. That's a good sign, I suppose. This would have been too easy, wouldn't it? Yeah, no, I don't think we are going to get anywhere like this. Definitely outputs a picture or a sync signal, but not much else. Not there yet, I suppose. We should at least get a gray screen or something, some reaction. Let's see if our power supply is at least providing the correct voltages. And so 12 volts, minus 12, plus 5. Should have another plus 5, I suppose. Oh, that's probably ground. Another ground. This is another plus 5, I think. Yep. Yeah, that all seems pretty good. Some troubleshooting is needed. Ah, bummer. Yeah, we're not quite there yet with a working system, but I did some further checks and I think I know what the next steps are going to be. Let me show you the current status of this. So I hooked up my Amiga 2000 keyboard to this because I don't have a dedicated Amiga 4000 keyboard, but that is totally possible with a regular size DIN to mini DIN plug connector. The keyboards are basically the same, just the connector is a different one. And you can buy these for PC keyboards. They work on Amigas as well. So you can easily hook up an Amiga 2000 keyboard to an Amiga 4000, just in case you didn't know. I also hooked up the power LED, the whole front bezel basically, to the correct connector on the board. And let me show you what I found. We still only have the black screen, so this is clearly not really starting up correctly. There are some preliminary checks you can do to easily figure out some things. So let me turn this on and show you what I found. So this powers on, it produces video sync, which is a good sign. I guess the graphics chip is getting voltage and some of the clocks are working. However, there is a relatively simple way to check whether the CPU is starting up, and that's by pushing the caps lock key a couple of times. And the LED should go on and off as long as the internal keyboard buffer has space to store the information. And then it should, if the machine started up correctly, it should be flushed by the processor, which it isn't, which is indicated by this just staying off no matter how often I push this. I can do the keyboard reset, and the caps lock flashes very briefly, and then I can do the same procedure again for a couple of times until I don't. So this means the CPU is not starting up correctly. Also, we can observe the power LED. If this would start up correctly, the power LED would start dim and then go bright after the reset sequence is toggled. So I'm turning this on. And as you can maybe see on camera, this just stays dim, so it doesn't go full brightness. Can you see that? Oh, yeah. This doesn't change at all. So I think what the matter is that the reset sequence is not triggered. There's a couple of troubleshooting guides for battery damaged Amiga 4000s online by Chucky Hertel, who also made the diagram, and he also made the re-Amiga boards, which are clones of the original Amiga 4000 boards, so he knows the Amiga 4000 in and out. Yeah, there are actually some clock lines that go through this area, and I suppose, that's what I suspect at this point, that I missed fixing one of those clock lines. So the next step, which is probably going to happen in the next video, because this episode is of considerable length already, partially because I screwed things up. I'm sorry for that. I'm going to have to do some in-depth troubleshooting, get out the oscilloscope and check the clocks on the board and things like that, and also check some more of these connections in this area that I probably missed fixing. I think we're making progress, but yeah, as I said, we're not quite there yet, and it's going to take at least another episode to fully troubleshoot this and hopefully fix it at some point. I hope so. I really, really hope so. Yeah, that's where we're at this point. I hope you enjoyed this episode, even though it didn't have a particularly happy ending. It had some drama. Sorry for that. I'm definitely going to continue this repair effort and try to revive this board at some point. I'm going to need some more time for this, and there's definitely going to be another episode once I have some more things figured out, maybe even with a happy ending that time. Thank you so much for your support on Patreon and on the channel memberships page and on Ko-fi, and also your single donations. Thanks again to Katrina for donating this Amiga 4000 to me in the first place. That's an amazing donation still, even if it doesn't work yet. We're going to see where this is going. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.